So I wanted to do number 4.
Number 4, let me screenshot this thing. So number 4, and then
Number 5 and 6.
number 5 and 6.
Yes.
Okay, so let's screenshot 5 and 6, and then
Um, Number 10.
number 10.
Yes.
It has got D, right? Part D also.
What did you say?
It has 4 parts, right? A, B, C, and D.
Yes.
Okay, and then
That's it.
cool. Now let me check all the parts one by one. So the first one is hello.
Yes,
Monet, are you able to listen?
I am.
But,
Are we doing number 4?
I don't know what's wrong, but I'm not able to.
Can you not hear see the screenshots?
No, I'm not able to see see the screenshots. Uh, we have got. What's the first question?
If a satellite orbited at the same
Yeah, I got
velo-
it. If a satellite orbited at the same speed around a planet with 3 times the force of Earth's gravitational, what would happen to the radius of the orbit, right?
Yes.
Yeah. So now let's get back to our question. Let me share the screen. Are you able to see the screen?
Yes.
Cool. So what's the question? If a satellite orbited at the same velocity around a planet with 3 times the force of Earth's gravitational force, what would happen to the Earth's orbit, right?
Mm-hmm.
So there is a satellite. Let's say this is our Earth, and there is a satellite. Let's say this is our satellite. Are you able to see the screen?
Yes, I can.
Cool. Now this is our satellite. Now let's say this is moving with the velocity of.
A velocity 3 times the force of Earth's gravity, so
Okay. Now let's say the satellite is at a distance of r. Then tell me what is the force exerted by the gravity due on satellite? What is the force exerted by gravity on satellite? Let's say the mass of the satellite is small m, and the mass of the Earth is capital M. Then what is the force exerted by the Earth on the satellite?
30.
Uh, I hope you remember this. The force exerted by the Earth on satellite. What is the force?
The force would be 3 times of Earth.
Yeah, that's absolutely correct. But do you remember the Newton's gravitation law of attraction?
Yes.
So what does it say?
that the third law, the equation, or what it says?
Yeah, it's something like this. If there are two masses, let's say m1 and m2, and both are separated by a distance of r, then the force of attraction between these two objects is given by F equals g times m1 m2 upon r square.
Okay.
So is this clear?
Yes, it is.
So now let's say that what is the force exerted by the gravity in this case?
Um, 3 times the force of Earth's gravity.
Yeah, g times actually this is a force due to gravity, and let's just use this formula. This is g, and mass of earth is capital M times mass of satellite is m upon r square, and this equivalents to 3 times the force of earth's gravity, right?
Yes.
So now let me tell you another concept. If there's an any object, let's say any object of mass m, and which is moving with a velocity v in a circular path of radius r, now the force experienced this particle is given by mv square upon r. So this is a golden rule which we need to remember.
Okay.
So any object which is moving with velocity v in a circular path with radius r, now this particle is going to experience force in outward direction, and this is known as a centripetal force. This is known as a centripetal force, and it is given by the formula mv square upon r. Now the same situation is happening here. There is a satellite which is moving in a circular path around the earth with the radius r, and let's say with the velocity v. Now what is the force acting on the satellite? Force acting on satellite is given by mass of the satellite. Let's say this is m. Here this m is nothing but mass of the satellite, m into v square upon r,
Okay.
right? Now what are they saying? They're saying that if a satellite orbited at the same velocity around a planet with 3 times the force of Earth's gravity, what would happen to the radius of Earth? So let's just treat.
No, yes.
So this satellite is orbiting like 3 times Earth's gravity. So let's just multiply by 3. 3 times Earth's gravity is 3 times, and Earth's gravity is given by 3m capital times m upon r square equals to mv square upon r. So let's just equal, r gets cancelled and m gets cancelled. So this r is given by 3g capital M upon v square. So this is the radius of a satellite which it is moving around the earth. This r is nothing but this 3g m upon v square, where v is the velocity of the satellite at which it is moving.
Okay.
Is this clear, Moy?
Yes, it is.
Are you sure?
What did you say?
Are you sure?
Yes.
Okay, shall we move on to the next one?
Sure.
So, what's the next question?
The next question is, I think I said number 5.
Mm-hmm.
Did you need me to read it?
Mm-hmm.
Okay. What will happen to the centripetal force if the mass of an object is doubled and the radius is cut in half?
Mm-hmm. Okay. See, Mone, the main idea is that centripetal force it is given by the formula mv square upon r. Let's say there is a particle of mass m, and this started moving around a circular path of radius r with velocity of v. Now the force acting on this particle is given by m times v square upon the radius of the circular path at which it is moving. So this is what the centripetal force is given by, right?
Yes.
So is this clear?
Do you mind explaining how that
Yeah.
if can you explain that again, please?
Yeah, sure. So the idea is that let's say there is a mass of let's say there is some mass m. It can be our Earth or any other planet. Now it started rotating about any object. Let's say there is a mass m, and it is tied by a string, and it started about a fixed point of radius r. So that means there is a mass m, and I'm started to rotate the mass m with a radius of r. Now the force acting on this m, it will be outward direction, and this force is given by m times v square upon r, where v is the velocity at which the mass m is rotated. So this is what we call it as a centripetal force. I hope you remember that in our previous session we discussed about the static friction, right?
Yes.
So what is the formula for static friction?
It's like I forgot the actual word for it, but it's static friction equals.
Yeah, it's equals mu times m times g, which we discussed earlier.
Sure.
Similarly, if there is a mass m and which is moving in a circular path, let's say this is a mass m, it can be anything. It can be either a satellite or it can be either a merry-go-round, which we see in a circus, or it can be a something you just tie a stone and you just start rotating in a circular path. Now this stone is going to experience a force which equals to mv square upon r. This is what a centripetal force is given by. This is the formula for centripetal force. Let's say the mass m started rotating about a circular motion of radius r. This is the radius r, and with the velocity of v or with the speed of v, then the centripetal force acting on this stone is given by mv square upon r. This is the standard formula which we need to remember.
Okay.
Is this clear, or you want me to explain this again?
I've got it. Thank you.
Yeah, great. So what are they asking about? They are asking that the mass of the object is doubled and the radius is cut in off, right?
Yeah.
So what's our formula? Our formula is that mv square upon r, right?
Yes.
Now they are saying that the mass is doubled. So what should I take as mass?
What should you want?
What should I consider the mass? If the mass is double, let's say the initial mass is m. Now what should I consider the mass so that the mass is doubled?
2m.
Yeah, exactly. So the final mass should be 2m. And also they are saying that
The radius is cut in half.
yeah, the radius is cutting off. So if the initial radius is r. So what should be our final radius?
1/2 r.
So what should be its value?
1/2 r.
Yeah, exactly. It should be r upon 2. Now let's say what is our initial centripetal force? Let's say our initial centripetal force is mass times velocity square upon r. Now what is its final centripetal force?
Can you say that again, please?
If its initial centripetal force is mass times its velocity square upon r, then what would be its final centripetal force?
I'm not sure. Like the final equation?
Yeah, it's just a final equation. We just need to substitute the final mass and final radius of the given object.
Okay, it'll be 2m
2m.
squared over
Mhm.
r
Is
over
this
2.
r upon 2, right? Yeah. So this would turn upon to be 2mv square upon r upon 2. This is just nothing but 4mv square upon r. So
How is 4mv squared?
we are just using this. Let's say there is a 1 upon 2 upon 4 upon 2. This is nothing but 1 upon 2 into 2 upon 4.
Okay.
Similarly, if there is something like 2mv square upon r upon 2, this is nothing but I can also rewrite it as 2mv square. So this is 2 times 2 upon r. So 2 times 2 is 4 and mv square upon r. So this is how we are getting 4 mv square upon r. I'm just substituting that the final mass as 2m and the final radius are as r upon 2.
Okay.
So that's how we are getting the final centripetal force acting on the particle as 4 mv square upon r.
Okay.
So as you can see that by what factor the final force has increased?
By what factor?
The final force has increased.
By 2?
Are you sure? Is that by 2?
By 4?
Yeah, exactly. Because initially the force is just mv square upon r. This is our initial centripetal force. Let me call it as CF. Now, what is our final centripetal force? Let me call it as CI actually. This is initial centripetal force. What is final centripetal force?
The equation?
This is 4 mv square upon r. So this is multiplied by 4 times, right?
Yes.
So the final centripetal force is 4 times the initial centripetal force.
Okay.
Yeah. So whenever we double the mass and reduce the radius by half, then the centripetal force is going to increase by the factor of 4.
Okay.
Yeah.
Sounds
Is this clear, Moni?
It is. Thank you.
Cool. Now, shall we move on to the next one?
Sure.
So what does the part B says?
I actually think I understand part B. Do you mind if we move on to number 6?
Cool, cool. That's really a good sign that you're learning. Now let's move on to the part 6. So what does the part 6 says?
A 50-kilogram girl is
Hmm.
riding her bicycle in
Mhm.
circles with a
Hmm.
radius of 5 meters.
Okay, now let's just analyze the situation. There is a girl. I'm sorry, don't mind me about the diagram. I'm not good at these things. Let's say this is a girl and she's riding a bicycle, right?
Yes,
So this is our bicycle. It has got two wheels. And what's the mass of this girl?
50 kilograms.
So let's say this is 50 kilograms. And what is she doing?
Riding her bicycle in circles with a radius of 5 meters.
So she is riding around a circular path. This is our circular path. And the radius is,
5 meters.
okay, this is 5 meters.
Yes.
So let's call it as 5 meters. And what they want us to find.
Well, it says it takes her 12 seconds to make one revolution.
So let's say she's starting. Oh, she's so beautiful. Now she started from here and it took 12 seconds to reach again here, right? So,
Yes.
so the time it took to reach back to her own position is 12 seconds, right?
Yes.
So what do they want?
What is her tangential velocity?
Okay, they want us to find the tangential velocity.
Yes.
Okay, they want us to find let's say she is moving with a tangent. Tell me more, what is a tangential velocity?
I'm not sure. I haven't heard of that before.
Oh, so you're missing your physics classes in regular base on regular basis, right?
On what?
You're missing your physics classes on regular basis.
No, I'm not missing my physics class. It's just we haven't talked about this.
Okay. You said that earlier also you haven't gone to the physics class that while Newton's laws of motion is going on.
I wasn't there that day, but I still didn't quite understand it as well as I would have liked.
Okay. Yeah, you are such a bright student. Even I do notice in our live session. You're doing great.
Okay, thanks.
See the tangential velocity, the idea of tangential velocity is as follows. Even in our previous problem that we saw that there is a mass of m and which is moving with a velocity v of radius r.
50 kilograms?
Now this v is nothing but our tangential velocity. The velocity with which the object is going is known as our tangential velocity. This v is nothing but tangential velocity. Uh,
Could you explain that again?
okay, is my voice not audible?
No, I can understand you.
Okay, let's say if there is a mass m which is moving around a circular orbit of radius r with velocity v. So this v is nothing but our tangential velocity. The v itself is known as a tangential velocity if it's not changing.
Mm-hmm.
See, basically there are two types of velocities. See, the tangential velocity is nothing but just a v. As per as your syllabus, I guess this is enough. We already studied that force due to the centripetal force is given by m times v square upon r, right?
Yes.
Which we just now solved in our previous problem.
Mm-hmm.
So this v is nothing but our tangential velocity. This is what they are asking about. So this is our tangential velocity. This v is what we need to find, right?
Yes.
But how do we find V? Is there any other information that is given?
Um, it says what is her tangent? I still can't say that, but that velocity. And then to the side it says 2.62 meters per second. But I
Okay.
just assumed that we're trying to find or prove that it's 2.26 meters per second.
Okay. But I guess they also said that it took her 12 seconds to cross one revolution.
Yes.
Yeah. So let's say this is her. Uh, I know that she is not beautiful, but still let us assume her. She took 12 seconds to move from, let's say this is position A. So she took 12 seconds to start from here and get back to here, right?
Mm-hmm.
So what is the distance covered by this lady?
The distance. If are we looking for the circumference?
Yeah, exactly. Wonderful. That's brilliant idea. We are trying to find the circumference, and that's what it is, the distance. So the distance covered by lady is nothing but the circumference.
Okay. I just need my calculator for this then.
Yeah, sure. So what's the circumference?
2 pi 5. Or
It's just 2 pi r. Just some basic mathematics.
yeah.
So 2 times what's the value of pi? Let's assume to be 3.14 for the God's sake. And r is 5 meters. So this is the circumference, right?
Yes, I got 31.41 for the circumference.
31.41.
0.41.
Okay, cool. This is cool. Now what's the time taken?
The time is 12 seconds.
12 seconds. Now we know that the velocity is given by distance travel upon time taken,
Mm-hmm.
right? Uh, Now the distance traveled is 31.41 and the time taken is 12 seconds. Now what's the value of this?
The value of distance over time.
Yeah, this is I hope you are familiar with this formula. Velocity is given by distance over time.
Over time. I got 2.6 for the velocity. Or 2.62.
Okay, so you're getting 2.62.
What did you say?
Are you getting 2.62?
Yes.
31.41 divided by 12, we're getting, yeah, you are right. We're getting 2.6175, which is approximately 2.62. This is not a very bad approximation. So let's consider it to be 2.62, right?
Equal. Yes.
So that's what they're asking us to find.
Okay.
So they're asking us to find what is her tangential velocity, and we just now found.
2.62. Okay, thank you.
Now, shall we move on to the next one?
Sure. There's a part B to this equation. To this.
There is a part B.
Yes.
So what does the part B wants?
It wanted to know the centripetal force.
Okay. See, it's just a centripetal force. I'm not good at pronunciation, but
You said
still.
it much better than I did.
So they want us to find centripetal force, right?
Yes.
So I just now discussed about this centripetal force. How do we find centripetal force, Moni?
The sun. Sorry, my computer just like logged out for a second. But the equation that we have is what
Mm-hmm.
was it? mv
Mm-hmm.
squared over r.
Wonderful. Oh, Moni, you are so intelligent, but you just sometimes you just want to show up.
Okay.
Now let's just substitute all these values. What's the value of m? What's the mass of this lady?
15 kilograms, 50 kilograms.
Okay, she's not so heavy. And what's the velocity?
The velocity is 2.62.
Okay, that's what we just now found out, right?
Yes.
And we need to square this term. So 2.62 whole square upon what is the radius?
The radius was 5 meters.
Okay, let's just substitute 5 and 5 times 10, and it's going to be 10 times 2.62 whole square. Now let me just calculate what's the value of 2.62 whole square?
2.62 squared. 2.62 squared is 6.86.
This is 6.86 times 10. This is going to be 68.6 Newton. So this is what the centripetal force the lady is going to experience.
Okay, thank you. I
Yeah.
understand that.
Is this clear up until what we discussed?
Yes, sir.
Sure. By the way, my name is Pawan. You can just call me
Um,
Pawan.
can you say that again?
Myself, Pawan. My name is Pawan. You can just call me Pawan.
Pawan?
Pawan.
I'm sorry, I feel like I'm not saying this right, but can you spell it?
Pavan.
Okay, so Pavan?
Yeah, exactly. Pawan.
Okay. Um, okay.
Now, shall we move on to the next one?
Sure.
So the next one is question number.
Question number, I think I want to do, I think I
Question
said,
number 10, I guess.
oh, 10? Okay.
This is our last question.
Yes.
Okay, so what's this question? What he wants us to do?
It says Jessica is riding a merry-go-round and sits 8 meters from the center.
Okay, just give me a break. There is a Jessica.
Yes.
So this is our. Okay, this is our Jessica.
Mm-hmm.
I'm sorry, I'm not good at drawing.
It looks pretty good.
Oh, thank you. So what is she doing?
She is riding on a merry-go-round and sits 8 meters from the center.
Okay, now she is riding on a merry-go-round. So this is our merry-go-round. And this is the only merry-go-round which is not in circular path.
Can you say that again, please?
This is the only merry-go-round which is not in circular path.
Oh.
Generally, it will be in circular path.
It says it's 8 meters from the center.
And the radius is 8 meters?
Yes.
Cool. And then?
Her sister Natalie is sitting 6 meters from the center.
Okay, her sister is somewhat closer to the center. So let's say this is her sister. She has got some long hair.
Mm-hmm.
This is her sister Natalie. And she is at a distance of 6 meters.
Yes.
This is her radius.
It says
Now,
the merry-go-round makes one full turn every 40 seconds.
the merry-go-round makes one full turn round about. So Either it is Natalie or her sister. They are taking 40 seconds to complete a single round.
Mhm.
And then
What is Jessica's linear or tangent? Okay, that one, that speed.
mhm,
So it's just asking us for the speed.
they're asking about tangential speed.
Yes, how do you say that?
Tangential.
Tangential?
Yeah,
Okay,
it's not what you're thinking about.
okay. So we're just looking for the linear tangential speed.
Yeah, exactly. So I guess I just earlier discussed how do we find this tangential speed. See, tangent is nothing but, let's say there is any curve, and if you want to find the tangent at this point, just given by this, you just need to draw a straight line, just touching that curve. So that's what we call it as a tangent. So
Okay.
let's say if you want to find the tangent at this point, you just draw a straight line which is just touching this curve. So that's what we call it as a tangent.
Because of the okay, I get it.
Yeah. Now, how do we find the tangential speed of whose Nautilus?
Jessica's.
Okay, we need to find tangential speed of Jessica, right?
Yes.
Okay, what is the so what is the formulas for tangential speed? Speed is nothing but distance traveled upon time taken.
Mm-hmm. So we would need to figure out the circumference.
Yeah, distance is nothing but circumference, and the circumference is given by
2 pi 8
2 pi 8 upon
over over
over.
40 seconds.
Yeah, 40. Now let's just substitute these values. 2 times 3.14 times 8 upon 40, 2 times 220, again 2 tens, 4s, and 3.144. Let me do this calculation. 4 4s are 16, 4 1
Yeah.
5, 4 3 is a 12, 12.1.256. I'm getting 1.256, which is very approximate to 1.26 meter per second.
Mm-hmm. I got that also.
Yeah. Is this clear about the first part?
It is.
Are you sure?
It is.
Cool.
I got it.
Yeah. So,
And
Mone, what is your physics teacher teaching about right now?
well, we just learned this today.
Okay, he just taught about this circular motion today.
Yes, we did.
Oh, cool. So, are you done with this Newton's laws of motion?
Have we what Newton's laws of motion?
Previously, we are doing this Newton's laws of motion, right? About the static friction and kinetic friction. That's what we are doing in our previous session.
Yes.
So, are you clear with those concepts?
Um, kind of.
Okay.
Like,
Mm-hmm.
some parts of it were confusing.
Okay. So that's why I'm saying you that I will upload these videos in my YouTube channel so that you might not find any difficulty. You can go through them again and again if you are fine with that, because I can't just upload with your permission without your permission. Uh, I just need
Yeah.
your permission to upload them in YouTube.
Okay, thank you. That would be helpful if it was on YouTube.
Yeah, you can just find it out, and I'll just provide you the link. Let me just share the link in the chat box to my YouTube channel.
Do you mind if you send it to text it to me, please.
Sure. But how can I send it to your text? Is there any WhatsApp number or any mail?
In the same group chat that we had before, you would just press send
Let
or
me.
just press share. I mean,
Okay, let me just check.
if you need help, you can share your screen and I can show you where you would share it.
Yeah, sure. I don't think. Let me just open the YouTube. Actually, the problem is that my PC is not able to perform over all these apps because I'm currently loading 3 to 4 Windows.
Okay. Well, then you can tell me the name of your channel and I can find it on YouTube. Because I am on my school computer and I don't have access to YouTube. They kind of block it.
Just wait. I'm going to share you. Okay. Right now you are on your school computer.
Can you say that? Can you say that again?
Right now, are you on your school computer?
I am.
Okay. I just now shared my one of my videos. You can go through that and then you can just subscribe to our channel, and then you need not to subscribe, you just need to go through our previous videos.
Okay.
Yeah. I will also do upload this video if possible, as soon as possible, so that you can revise them.
Trying to see if it'll work here.
Sure.
Let me at least see the page. Because our school kind of gave us Chromebooks, but they block out certain sites so that we can only do schoolwork. So I can't really access YouTube on here.
Oh,
But I can on my phone.
okay. Yeah. But you can use your phone.
Why I can use it on my phone?
Yeah, you can use it on your phone.
Yes. I think I found you.
It's just Zero Doubts. The channel name is Zero Doubts. We got a very few subscribers, like 30. It doesn't matter.
Okay, I found it.
Great.
Okay, thank you.
Yeah. So you can find all our videos in this YouTube channel, so that whenever you want to get back to our videos, or whenever you just want to revise these concepts, you just come back to our channel, and then you can just go through these videos.
Okay,
I
thanks.
hope this is helpful, right?
It was.
Sure. Now, shall we move on to the next one?
Yes.
So where were we?
We're looking for Natalie's linear
Mm-hmm.
I'll get it one time. Okay, tangential speed. There we go.
Oh man, why are you not able to spell that?
Say it or spell it?
Say it.
Oh, I don't know. Just some words are kind of hard for me to pronounce.
Okay, leave it. It's just tangential. That's what we say in our country.
Okay.
So what is Natalie's linear tangential speed?
Yes.
So how do we calculate this tangential speed?
We can do it the same way we did with Jessica. So it would be 2 pi 6 over 40 seconds.
2 pi times 6 upon 40 seconds. Yeah, I know that you were really intelligent from the very beginning. You just solved it in minutes, seconds.
2 pi 6.
So what its value? Now let's just substitute these values. 2 times 3.14 times 6 upon 40, 2, 220, and 2 tens, 2 threes, and 3.14 into 3. This is going to be 3 4 12, 3, 4, 3 is 9. So is this going to be 0.942 meter per second, right?
Yes, but I rounded it to 0.94.
Yeah, because that's what given in a solution, right?
Yes.
I know you are very intelligent, Moni.
And then the next one, it says, what happens to the linear speed as you get closer to the center?
You say what happens to the linear speed as we get closer?
Yes, to the center.
Mhm. So what happens? I just want to know about the force experienced by the person as we get closer.
The linear speed decreases.
So let's say there are two sisters. Do you have any siblings?
Yes, I have three.
Three.
Yes.
So what are they studying?
Can you say that again, please?
What are they doing? What are they studying?
Oh, well, my brothers are a year below me. They're sophomores in high school,
Okay.
and my sister is in college, and she's a med student.
Okay. Okay. Cool. Right now, actually, I'm also in teaching field, teaching for people who are preparing for medical. Like there is a exam called NEET in our country, in our India, called NEET, where it's an entrance examination for med schools.
Oh, so you teach them?
Yeah, I teach to these students who are preparing for med schools, physics.
Okay.
So what is the do you guys have any entrance examination for med schools?
I would assume so, but I'm not completely sure.
Oh God,
I
you're
think
not even bothered about your sister,
no, I do remember that she had to take a test, so I think that was it.
but you don't know what test it is, right?
I do not.
Oh my God, cool. So she's doing med. Is she already joined or is she preparing for med?
She's going next semester.
Okay, she's going next semester. Cool. So what about your brother? What is he doing now?
What is she doing now?
Yeah.
Oh, she's working.
No, no. What about your brother? He.
What are my brothers doing?
Yeah.
Oh, they're in a grade below me, so they're they're just in high school
Okay.
and they're football
So,
players.
oh, cool. So is he focusing on his studies? Is everything cool?
Um, they have good grades. I wouldn't say perfect,
Okay.
but they have good grades.
Yeah, I believe so because since you're good at studies, I hope your brother is also doing great.
Yeah.
Yeah. So now let's get back to our question. So it says that what happens to the linear speed as you get closer to the center? So you tell me, Moni, what happens to its linear speed as you get closer to the center?
The linear speed decreases as we get closer to the center.
Linear speed gets decreases.
Yes.
Why?
Why?
Mm-hmm.
Oh, because the force is less.
Exactly.
Okay.
Uh, See, this is by the way, what's your sister's name?
Melody.
Melody. Since she's elder, let's say she's your sister,
Okay.
and this is Monet, or you can say this is you. You see, you are much closer to the center, right?
Yes.
More than your sister. She is much far away from the center, right? So what is the force she is going to experience? Let's say this radius is r1 and you are at a distance r2. Now the force experienced by your sister is going to be m v square upon r1, right?
Yes.
Now what is the force experienced by you or the force experienced by Monet?
The force for me,
Yeah,
it would be mv squared over r. I mean not r, but pi squared. Pi 2.
yeah, this is r2 because I'm just assuming that you are at a distance of r2, right?
Mm-hmm.
Now let's
It's
say
a.
both can experience the maximum force of F because if something heavier force, if you are going to experience some heavier force, then you don't feel comfortable. You obviously you're going to just feel some physical things. You might vomit or something might happen. So let's say you both can tolerate a force F. This is a maximum force you both can tolerate.
Mm-hmm.
So what is the velocity, the maximum velocity which you can move? From here, you can see that the maximum velocity with which your sister, what's her name? Uh, let's
Ellen.
say, let's say it has sister only. F sister is given by, the maximum velocity is given by F square is given by F R1 times M, and velocity is given by under root of F R1 times M, right?
Mm-hmm.
And your velocity, your maximum, this is the maximum velocity of your sister, and the maximum velocity of you is given by F times this is R2 times M.
Okay.
So who has got the more velocity?
The most velocity, my sister.
Yeah, exactly, because the one who has got the more radius has got the more the velocity which they can withstand.
Can you say that again, please?
uh, the idea is that, see, the velocity is directly proportional to square root of r, because the force which they can withstand is same, and let
Okay.
us assume the mass is also same. So we are getting the velocity is directly proportional to square root of r.
Okay.
So higher the radius, we need to move with a more velocity.
Move with more velocity.
Yeah, because you see, we are getting it as square root of uh, f times r upon m. So if there is a more velocity, if there is more radius, if your sister is farther from you, so that means she requires more velocity to adjust to that maximum force she can experience.
Mm-hmm.
Even you can see that if you are standing at the center, that means you're not at all rotating, right? Let's say if there is a merry-go-round in a circus, let's say you went to an exhibition on one day, and you're standing exactly at the center. Now you don't experience any force, but the one who is at the far away from the center is going to experience a lot of hell. Is he's going to experience a lot of centripetal force. So
Okay.
because its velocity is also going to be high, because its velocity is directly proportional to square root of r, which we just now found out. Let me write it. See, F is equals to mv square upon r, and from here you can see that v square equals to f times r upon m, and v is given by square root of f times r upon m, right?
Yes.
So this velocity is directly proportional to the radius r. If you are at farther from the center, that means you need to move with the higher velocity.
Okay.
So that's the idea.
Mm-hmm.
And that's what the second question is all about.
Okay, I understand that.
Now, what's about the third one?
The radius of their orbit. What did you notice about the results? What would the units of this quantity be?
Okay, let's just. Mone, are you able to listen to my voice?
Yes.
Okay, what are they asking? Divide each girl's speed by the radius of their orbit. What do you notice about the results? What would be the units of this quantity? We just now derived that. Let me just clear this. We, oh God. We just now divide. We just now found that v equals to square root of f upon f times r upon m, right?
Yes.
Now let's just divide by radius r. Now it's going to be, let's say, v is nothing but square root of f times r upon m. This is what we just now found. Let me clear and start from the beginning. We know that F equals to, what is the centripetal force?
For Jessica?
Yeah, for anyone who is moving with a circular, who is moving in a circular orbit of radius r with a tangential velocity v.
So you mean like the general formula?
Yeah.
Okay, mv squared over r.
Exactly, mv square over r. And what is the velocity?
The velocity is 1.26 meters.
Is just f times r square upon m, because I'm just pulling this r square to the right hand side and m over, and I'm just getting square root.
Okay.
Are you sure this is clear? How we got from f to v?
Why did you have to square it?
Because you see f equals to mv square over r. Sorry, this is r. I'm sorry, I'm really very sorry. Let me just erase this. This is just r.
Okay.
So f equals to mv square over r. Now v square is given by f times r, and f times r upon m, because I'm just bringing over here and dividing this here. So that's what we are going to get. And v is given by, we just need to square root this equation. And that's how we are going to get f times r upon m.
Okay. Let me write that down.
So is this clear? How we are
Yeah.
getting this conversation from f to v?
It is.
Yeah. So v is directly proportional to square root of f times r over m. Now what they want us to find?
They want us to, it says, what do you notice about the results? What would the units of this quantity be?
Before that, they also want us to find something else. They want us to divide by radius r, right?
Mm-hmm.
So they want us to divide with the velocity v times r.
Okay.
So what are we going to get? V times r is nothing but, let's substitute v. V is nothing but f times r over m upon r, right? So this is nothing but, let's say, square root of a times b is nothing but square root of A times square root of B.
Mhm.
Are you familiar with this one?
Yes.
So what is square root of F times R over M? This is nothing but square root of F times M times square root of R. I'm,
Why?
because instead of A, I'm considering F over M as a single term as A and B as R. So
Okay.
this is the same thing as above value. The same thing. I'm just rewriting in the different way.
Mhm.
So what are we going to end up with? What we are going to end up with is this square root of F times M times square root of R times R. Because this is just a constant, which we just now pull it out of, we just separated these two terms. So square root of F times over M times square root of R times R.
Mhm.
So are you sure this is clear up until what we discussed?
Yes.
So now tell me what is, this is some constant. I don't want to give some importance to this term because this is not a, this is just a constant. The force is constant, the mass is constant. You're not going to change your mass just by rotating in any merry-go-round circle, right?
Mhm.
Until and up till we just vomit. So this is a lit. I'm just assuming that this is a constant, and the maximum force we can bear, or the maximum force with which we can withstand, this is also constant. So let me call the whole thing as constant. This is a constant C. So this is V upon R is nothing but C times square root of R times R.
Um, could you explain how you got that again?
Yeah. Uh, uh, are you did you understand how we got up till this point? Square root of F times M times square root of R times R.
Yes.
So what I'm trying to say is that I'm just assuming that square root of F times M, this is nothing but a constant, because F is a constant, this is a constant, and M is also a constant. So square root of F over M, this is also going to be constant. This is a constant value, and I'm going to call this constant as C. So the name I'm going to give to this value, square root of F over M, is C.
Okay.
So that's what I'm substituting here. The C over here times square root of R over upper R. So are you sure this is clear, Mone?
Yes, it is.
Shall we move on to the next part?
Sure.
No, because we haven't completed this one.
We have what?
We haven't done with this part yet.
Okay.
Now tell me what is the value of this part? Square root of R upon R.
Mhm.
Mhm.
So, are we looking for Jessica's radius or Natalie's?
I just want to know how what is a simplified version of this value, if I can express in single terms of R.
Would it just be like
Mhm.
radical R?
I just want some mathematical simplification form.
I'm not sure.
Yeah, I just want some mathematical part. You just tell me what is the value of square root of 3 upon 3?
3/3.
Mm-hmm.
Isn't it just one?
No, it's not 1. Monet, 3
Point-
over 3 is 1. This is 1, right?
Then 0.57.
Oh, you're just using calculator. I know.
Okay.
No, dear. I don't want you to use calculator. I know you've been answering great from the beginning. So you just tell me how can we simplify this? Do you have any idea? Like, do you remember anything from your maths class?
Yes, but not how to simplify radicals like this.
Okay. Now you just tell me what is the value of square root of 3 times square root of 3?
Square root of 9.
No. 3 times 3 is 9.
Mm-hmm.
But what is the value of square root of 3 times square root of 3?
I'm not sure.
It's just 3. You see, actually, I'm not able to create a new page. If I rub this whole part, I don't know whether I'm able to come back to this part or not. So let me just erase. Uh, let's erase this part.
Mm-hmm.
Okay. Simone, let's say there is a square root of 3 times square root of 3. Now, what is this value?
3.
It's just 3 because you see, what is 5 times 5?
25.
Yeah, it's just nothing but 5 square and it is 25, right?
Mm-hmm.
And similarly, square root of 3 times square root of 3 is square root of 3 square, and this is nothing but 3.
Okay.
Now, what is the value of square root of r times square root of r?
It would just be R.
Yeah, exactly. This is just r. So let's just substitute r as square root of r times square root of r. So our v upon r, it's going to be c times square root of r times square root of r times square root of r.
Okay. So it would just be.
So this square root of r in numerator and denominator, it's going to get cancelled.
Mm-hmm.
So we are going to left with c upon square root of r equals to v upon r. That's what we need to find.
So V over R is what we're looking for.
Yeah, exactly. That's what they're asking, right? They're asking that divide each girl's speed by the radius of their orbit. So I'm dividing their speed with the radius and I'm getting c over square root of r, where c is some constant. I don't know whether it can be any value. I'm not worried about this value right now.
Mm-hmm.
So finally what we are getting is this v over r over the speed over the radius of this whatever the circular path this girl is moving. This is inversely proportional to square root of r, right?
Mm-hmm.
So what is this v upon r represents? This is nothing but omega, which we call it as angular velocity.
Okay.
So just like how we define velocity, we define velocity as the distance traveled upon time taken, right?
Mm-hmm.
Similarly, the angular velocity is defined as the angle rotated per unit time. So this is how we define it as the angular velocity. So if you are rotating faster, like let's say you are trying, you can complete a circular motion, or you can complete a merry-go-round in 3 seconds, and your sister is completing the same merry-go-round in 6 seconds. Now, who has got the more angular velocity?
Can you say that again, please?
Yeah.
It just cuts out sometimes.
No problem. Let me share the screen. Are you able to see the screen
Not anymore.
now?
Okay, now I can.
Yeah. Let's say this is your sister, and this is you. Okay.
Mhm.
Now you are trying to complete this is your let's try, this is your sister, and who came back to the original position in 2 seconds. Sister completed the whole rotation in 2 seconds, and you completed the whole rotation in 1 second. Now tell me, whose angular velocity is greater?
Mine,
How?
because I'm closer to the center.
No. Obviously that's also being said, but yeah, that's also one of the reason, but still I just want some rigid point.
What are you asking?
How can you say that your angular velocity is same? Okay, let me give you another example. You're saying that you are closer, right? Now let me go with another example. Again, this is your sister,
Yes.
and she is at a distance of let's say 10 meters. Okay, and this is you, and please I'm really very sorry for drawing these things not with perfection. And let's say this is you, and I don't know whether this is 5 meters, and you are completing the circle within 2 seconds, and your sister is completing the circle within 1 second. Now tell me, who is moving with a greater angular velocity?
Would it be my sister then?
Oh, but earlier you said that's you who is moving with greater angular velocity because you are closer to the center. Now also you are closer, but why are you changing your answer?
I'm not sure.
Okay. Okay, then tell me what, how do we define the angular velocity?
Can you say that again, please?
How do we define the angular velocity?
I don't know.
Oh, dear, we just now discussed that angular velocity is defined by uh, theta upon t, or I can say the angle rotated per unit time, right? So this is a basic formula for our angular velocity.
Mhm.
So now you see, you came from here to here. So what is the angle covered by you? So you took the whole complete one revolution. So what is the angle covered by you?
360.
Yeah, exactly. So the angle covered by you, so omega by u equals to the angle covered by you. This is 360 degrees. Upon what is the time taken by you?
40 seconds.
No, you took only 2 seconds.
No, 2 seconds.
Yeah. Now what is the angle covered by your sister? She came back to the same position. And what is the angle covered by your sister?
360.
Yeah, because this is also 360, because she also successfully completed a whole revolution. So she also came back to the same position. So she also covered 360 degrees. And what's the time taken by her?
1 second.
So this is 1 second. Now tell me which who has got the higher value, either you or your sister. Your sister has got a 360 upon 2. This is 180, and sorry, you got 180 and your sister has got a 360. Now who is greater?
My sister's is greater.
Yeah, exactly. So now, but who has got the greater radius? Who is closer to the center?
I'm closer to the center.
Yeah, even though you are closer to the center, but still your sister is having the higher angular velocity,
Mhm.
right? So the basic idea is that the angular velocity depends upon the radius. That's a different thing, but the basically how do we define the angular velocity is the angle rotated upon the time taken. And also this is also known as v upon r, and this is how we calculate the angular velocity.
Okay.
Because we just now solved the tangential velocity v equals to 2 pi r upon t, right?
Mhm.
So from here you can see that what is 2 pi upon t? 2 pi is the angle covered. 2 pi is nothing but 360 degrees, and t is nothing but the time taken. So v is equals to theta, because 2 pi is the angle, upon t times r.
Mhm.
Is this clear how I'm getting through this equation? This is
Yeah.
2 pi upon t,
Mhm.
because earlier we also calculated the tangential velocity, how this is 2 pi upon circumference upon t.
Can you say that again, please?
Earlier also we calculated that the tangential velocity is nothing but the circumference, which is nothing but 2 pi r over t, right?
Yes.
But what is 2 pi? 2 pi is nothing but the angle covered, or I can say 2 pi is nothing but 360 degrees. 2 pi is equivalent to 360 degrees, right?
Yes.
Or I can say this is nothing but the angle covered, or I can say this is nothing but theta.
Oh, okay. I see.
So this is theta upon t times r. So v equals to theta over t times r, right?
Yes.
But what is theta over t?
What is theta over t?
That's what angular velocity is. That's what we are just now discussing about, right?
Okay.
So v is equal to the angular velocity times r. So angular velocity is nothing but v over r.
Okay.
So is this clear, Mohit?
Yes, it is.
So I hope we are done with all problems for today.
Yes, sir.
Yeah, sure, Monet. We'll meet in our next session.
Okay.
And wait for a minute. We started at 1:45, I guess, and we are ending at 3:30.
Yes.
Yeah, we just took for more than an hour.
Mm-hmm.
Okay, then we'll meet in our next session. So when are you going to meet in our next session?
I'm not sure. I'll have to see when our test is.
Okay, cool. Okay, bye. All the best for your test. Bye.
Okay. Bye.